I think it's the cosmological constant. I think it was. I think it's right. I have reason, internal reasons for that. But let's say that this is right. It's a cosmological constant. The universe expands and expands, exponential expansion. Now you might ask, who's in this universe eventually? Not us. The black holes will all have evaporated away by Hawking evaporation. They've swallowed galactic clusters. What's left in the universe? Pretty well photons. Now, I'm giving you the simplified version of the theory because there's some questions about it still. But let's say it's dominated by photons, which is pretty well true, but not. Let's take that.
Okay.
Now, the trouble with photons is that they don't feel the passage of time.
Right.
And more importantly, the equations governing light are the wonderful equations due to James Clerk Maxwell, the Maxwell equations. And the Maxwell equations have a very interesting property, that they can't tell big from small. They're what's called conformally invariant. That if you have a system in which you've got some electromagnetic field, and you could stretch this system to bigger or smaller, it doesn't notice the difference. The equations work just as well. And you can squash them here and stretch them here.
Well, and is that in part because space really doesn't mean anything to a photon?
In a sense. Well, it's the scale of space. You see, it's what we call, there's a term which I'll use here, it's called conformal. Conformal means big and small. I very much like, we talked about Escher a minute ago. There are these Escher pictures called circle limits, where he describes what's called hyperbolic geometry, but don't worry about that. The most famous one is these angels and devils. And you see there's a circular boundary. And they look as though they get smaller and smaller and smaller as they get to the edge.
Yes.
Now, as far as those angels and devils are concerned, the little ones are just the same as the big ones.
Right.
They don't know that they're smaller towards the edge. And that, to them, is an infinite universe. But to us, we can see, no, there's this infinity, which is just sitting there. And these angels and devils, if they don't know big from small, I'm not sure, I have a bit of trouble using this to explain things because the angels and devils do have a size in the picture. But you see, if they were made of massless material, that wouldn't know big from small. So if they were made of just electromagnetism, then big and small are equivalent. And so you wouldn't know when you got to the edge of this universe. So that infinity is just like anywhere else. That's the difficult concept in this thing, that the photons